When you sit down to code a new video game, you probably expect the computer to be pretty smart. Out of the box, Python understands basic logic. If you give it a standard math equation, like 5 plus 5, it easily calculates 10. But if you invent a brand new character, like a custom robot, and try to use a normal plus sign to give it a battery, your game immediately crashes. This happens because computers only understand built-in numbers. They have zero instructions for how to combine completely new concepts. In Python, when we want to build a custom creation, like our video game robot, we put it inside a digital container called an object. When an object is first created, it is a blank slate. The computer makes zero assumptions about what it can do or how it interacts with the world. To make our object playable, we have to act as the game designer and teach Python exactly what normal symbols and commands mean for this specific character. We do this using what are called magic methods. These are internal instruction manuals that tell your custom objects how to behave. Programmers call these dunder methods because the instructions always begin and end with a double underscore. This diagram shows our first essential dunder method, dunder init, short for initialize. It acts as the blueprint for how the robot is built. When we type the command to create a robot named Sparky, the method follows the blueprint and assembles the parts. Without that blueprint translating our command, the game would have no idea how to assemble the character in the first place. This graphic shows a new problem. If we ask Python to display our completed robot on the screen, the computer outputs confusing machine memory code. We fix this with the dunder repr, or representation, method. This instruction tells the computer to give the object a clean, readable identity. Now, instead of a messy string of letters and numbers, Sparky returns a friendly greeting. Swapping out the machine's default label for your own is essential because it translates the computer's internal tracking into human language the player can actually understand. Let's go back to our initial conflict, the game crashing when we try to add a battery to Sparky. This diagram introduces dunder add. This specific instruction intercepts the plus sign and gives it a brand new meaning for our robot. Now, when we use the plus sign, the method safely processes the battery item, and Sparky powers up without breaking the game. Mathematical symbols aren't fixed rules. Dunder methods allow you to completely redefine them to mean whatever your custom object needs to function in the game world. Even normal, everyday numbers in Python use these same pre-written instructions behind the scenes to do math. You can prove this using the dir command. Think of dir as a flashlight that lets programmers peek at the hidden dunder methods inside any object. This terminal output shows what happens when we shine that flashlight on a standard number. It reveals a long list of dunder methods tucked away inside, including familiar ones for adding and multiplying. Mastering Python means realizing there is no default behavior. The entire language is built on these editable instructions. There are dozens of different dunder methods available for almost every symbol, action, or comparison you can imagine. Here, we are using the dunder LT, or less than, method to teach the robot how to compare its size to a boss character, using the standard less than math symbol. Writing dunder methods gives your unique creations the vital instructions they need to interact with your game world and follow your own rules.